Now we will talk about one of the component of bile, which is bilirubin, right? Bilirubin is used as a diagnostic tool for liver diseases and some diseases related to blood, right? When we say it's used as a diagnostic tool, that means we go for a blood test, and if your blood test shows more than the normal range of bilirubin, it indicates some kind of liver disease, right? That means your liver is not functioning properly, or some kind of blood deficiency, maybe anemia, right? We'll now talk about it. And we'll also go through the formation of bilirubin and its excretion in feces and urine. So, as a diagnostic tool, it's used to diagnose liver diseases, right? In liver diseases, we know that our liver secrete bile, right? And this bile is stored in gallbladder, right? And in response to food in the duodenum, your gallbladder will start releasing bile into your duodenum, right? Now, since your hepatocytes, right, the hepatic cells or the cells of liver are secreting bile, in case there is any issue with the liver cells, right, the liver cells will leak and the bilirubin will enter into the bloodstream. So, if you go for the blood test, your blood stream, or your blood will show higher level of bilirubin, higher than the normal range, right, which indicates some kind of liver disease, right. So, maybe your hepatocytes leak and your bilirubin enters bloodstream, right. So, blood will show higher level of bilirubin, right. Now, if we talk about some blood related disease, bilirubin is formed by degradation of hemoglobin, right. When hemoglobin breaks, right, we'll just talk about how bilirubin gets formed. So, for now, just understand that bilirubin is formed by the degradation of hemoglobin, right. Now, if there is too much of bilirubin in your blood, right, that means there is too much decomposition of hemoglobin, right, and hemoglobin even though is one of the component of your blood, right. So, it may relate, right, you may relate it to some kind of blood disease, right, maybe anemia, where your hemoglobin level goes down, right. So, the case may be that your hemoglobin is undergoing abnormal degradation, right, and producing too much bilirubin that is now showing up in your blood report, right. So, here your hemoglobin degradation produces bilirubin, right. Now, abnormal degradation, let's write it like this: high level of bilirubin, in blood points to abnormal degradation of HB, hemoglobin, right. So, these are two things, right, for which we go for a bilirubin test, right? Now let's look into the formation of bilirubin, right? Bilirubin is formed from the degradation of hemoglobin, right? And we know that hemoglobin is in blood, right? And the red color pigment, it's a red color pigment that gives red color to your blood, right? So hemoglobin, and it's a normal process. When I say hemoglobin degradation, it's a normal process when your red blood cells, right, when your red blood cells reaches their lifespan, which is of 120 days, right, their cell wall ruptures, right, and the red blood cells will release hemoglobin, right, and this hemoglobin will undergo further degradation into globin, which is the protein part, and your heme, right, heme, which is an iron porphyrin, right. Iron porphyrin means you have iron atom which is coordinated to the 4 tetrapyrrole rings, to the 4 pyrrole rings, I'm sorry, it's a tetrapyrrole, right, and the pyrrole rings in heme is linked, or is pyrrole rings are bridged by methylene bridges, right, methylene group. So your globin, it will degrade by a normal process since it's a protein. So globin part will degrade into your amino acids, right, and it's your heme part, right, that will release iron, right, iron is in ferric state, +3 state, and your iron free heme ring, right. Now this iron, right, would be absorbed by the blood. It is recirculated in the blood by transferrin, right, and your heme ring, right, heme would be oxidized, iron free heme, because iron, like I said, iron is recirculated into the blood by transferrin. Now the remaining portion of it, which are your 4 tetrapyrrole rings, right, linked by, or they are bridged by methylene groups, right. I'll show you the structure, how it looks like. Now your heme, it will undergo oxidation, right, where it will form a straight chain that has 4 pyrrole rings, right, and methylene bridges between. We call it as biliverdin, right, biliverdin. Then biliverdin will undergo reduction, right, by an enzyme, reductase enzyme, to form bilirubin, right. This is how bilirubin will get formed. So your heme ring, heme will undergo oxidation with oxygenase. Oxygenase is an enzyme that will oxidize your heme to form biliverdin, right, and biliverdin will undergo reduction, right. In this reduction reaction, one of the methylene group will get reduced, right, that is, hydrogen would be added to it to form methyl group, right, and it will form bilirubin, right. Mostly the reaction part, right, the chemical reaction, we will deal in more detail in biochemistry, right. This is physiology, so we would be looking more into how diagnosis would be done, right, and how your body excretes it, right, how it gets formed and how it gets excreted, right. The chemical reactions would be done in detail in biochemistry, right. I'll show you the structure part. So this is your bilirubin, right. Now this bilirubin is your non-polar molecule, right. So in the cells, right, in the cells it gets coordinated, or it gets linked to lipids, right, inside the cells, right. So in order to remove it, you need to convert it, or the body needs to convert it into the soluble salts, right? So what happens is bilirubin in this form, right, would be attached to plasma albumin, right? Plasma albumin is the component of blood, right? So bilirubin will attach itself to plasma albumin, right? And in this combination, right, in combination with albumin, it would be circulated throughout the body with blood, right? And in some time, in this form, that is bilirubin plus albumin, right, in this form, it would be absorbed by the hepatocytes, right? Now inside the hepatocytes, what happens is, since I said this bilirubin is a non-polar molecule, right, which needs to be converted into a soluble form, into a polar form, right? So inside the hepatocytes, bilirubin will combine with glucuronic acid, right, and sulfate, right, to form bilirubin glucuroside and bilirubin sulfate. And it is in this form, right, in the form of glucuroside and your sulfate, that bilirubin would be excreted, right, in the bile, right? So I hope till this point it is clear, right? So now bilirubin, right, it's in this form, it is circulated in your body, right? Then in some time it would be absorbed by hepatocytes, your liver cells, right? Now in hepatocytes, what happens is it gets conjugated to glucuronic acid, absorbed by hepatocytes and gets conjugated with glucuronic acid and sulfates, right, to form bilirubin glucuronoside and bilirubin sulfate, to form bilirubin sulfate and glucuronoside, right? And it is in this form that it is excreted by the liver cells. So liver cells excrete bilirubin in the form of these soluble salts in bile, right? And it is in this form that they move into intestines. Now let's see what happens to them, to these soluble forms, when they are in intestine, right? So in intestine, I'll just write it over here, this bilirubin glucuronoside, right, and bilirubin sulfate, right? In your intestine, these forms, or we may say bilirubin, right, would be acted upon by bacteria, right? Now this bacteria will convert this bilirubin into urobilinogen, right, which is a highly soluble form. This is a soluble form, and some of it would be absorbed by your intestines, right, by the intestine wall, intestinal mucosa, right? So some of it would be absorbed by intestinal mucosa, right, and some would be excreted in the urine, right? Some would be excreted in urine, right, and some will be excreted in feces, right? Now in urine, right, urobilinogen when excreted in urine, right, when it moves out, when it moves out of the body through urine, it gets oxidized in air, right, to form urobilin, right, it gets oxidized in air to form urobilin, right, and when it is excreted in feces, it forms stercobilin, right, that gives the color to your feces, right. So in the feces, it is altered and oxidized. In the feces, urobilinogen is oxidized. Urobilinogen is altered and oxidized to stercobilin. Right, in feces, it is altered and oxidized to stercobilin. Right, and it is the stercobilin that gives color to your feces, right. So I hope this is clear how it is made and how it is excreted. Right, so once again we'll just quickly go through it. Firstly, it is used as a diagnostic tool, right, it is used as a diagnostic tool for liver diseases and for blood diseases, right. If you have a liver disease, then possibly your liver cells are not functioning normally, right, and what they do is they, instead of excreting your bilirubin in your bile, what they will do is they will start leaking bilirubin, right. So when your hepatocytes will leak bilirubin, it will enter the bloodstream. So your blood test will show your higher range or more than normal range of bilirubin, right. Similarly, for blood diseases, we know that this the bilirubin is formed by degradation of hemoglobin, right. Hemoglobin degrades into globin and heme, and from heme your bilirubin is formed, right. Now if your blood shows higher level of bilirubin, right, then it might be the case that your RBCs, right, are degrading fast, right, or RBCs are getting ruptured fast, because bilirubin is formed by a normal process where when the lifespan of RBCs reaches, right, of 120 days, then your red blood cell will rupture and will release hemoglobin, and from hemoglobin your bilirubin is formed. Now hemoglobin will break into globin, which will degrade into amino acids. The heme part, right, the heme part, right, it is an iron porphyrin ring, right, where you have iron, right, iron coordinated to 4 tetrapyrrole rings, right. I'll just show you the tetrapyrrole rings, how it looks like. Right, these are the tetrapyrrole rings. These are the 4 pyrrole rings. Sorry. Right, like I said in the beginning, that these pyrrole rings are further linked, or further they are bridged by methylene bridges. Right. Right. So you have this is how it looks like. Right, these are 4 pyrrole rings. You have iron. Iron is coordinated to 4 pyrrole rings, and these pyrrole rings are linked by methylene bridges. I'm sorry, I'm drawing it very big. Right? These are methylene bridges. These are pyrrole rings, and iron is coordinated to all the pyrrole rings. These are side chains. We'll be looking more into its chemistry in biochemistry subject. Right, this is your hemoglobin. Right, this is your hemoglobin structure. This is how the structure of hemoglobin looks like. Right, if you are unable to see this, this is above this we have this side chain, COH group, then COOH group. Right, now when this hemoglobin will degrade, right, the globin part will separate, and this is your heme ring. I'm sorry, this is not hemoglobin, this is heme ring. Right, so in this heme ring, this iron, right, this iron would be recirculated, right, by transferrin and would be absorbed by blood. Iron is absorbed by blood. Right, now this heme ring, right, this will oxidize into a straight chain 4 pyrrole rings, right, which are linked by methylene bridges, right, which is further reduced by your reductase to form bilirubin. Right, first this will form biliverdin like here by an enzyme oxygenase, then biliverdin will undergo reduction to form bilirubin. Right, now bilirubin, this is an unconjugated bilirubin at this time. Now this will get conjugated with albumin in combination with plasma albumin. It will circulate in your blood, right, and would be finally be absorbed by hepatocytes. Inside hepatocytes, bilirubin, which is a non-polar molecule, would be converted into soluble salts, right, by getting conjugated with glucuronic acid and sulfate, right, and they will form bilirubin glucuronoside and your bilirubin sulfate. In the form of this sulfate and glucuronoside, it would be excreted in the bile. Right, now in this form only, right, inside your intestine, right, it would be acted upon by bacteria, and bacteria will change it into urobilinogen, which is a highly soluble form, and would be absorbed by the intestinal mucosa, by the wall of the intestine. Right, and some would be excreted in urine, where outside your body would be oxidized to urobilin. Right, in the excrete, in the feces, where it is excreted in feces, it is altered and oxidized to form stercobilin. It is stercobilin that gives brown color to your feces. Right, I hope this is clear. Thanks.